Welcome to Get Your FRQ On. This question is from 2015. It's question 3, and it is not calculator active. In the question stem, we have Joanna running along a straight path. There is a table of data for values of t and values of v of t. And v of t is measured in meters per minute, and t is measured in minutes. In part A of this question, we are asked to use the data in the table to estimate v prime of 16. V prime of 16 can be approximated by using the formula for the average rate of change. And based on the information in the table, it's probably best to use t equals 12 and t equals 20. So v prime of 16 would be v of 20 minus v of 12. All over 20 minus 12, which is 240 minus 200, all over 8, which is going to be 5 meters per minute per minute. In part B of this question, we are asked to explain the meaning of the definite integral from 0 to 40 of the absolute value of v of t dt and to approximate this value using the right-hand Riemann sum with 4 rectangles. Since the definite integral is of the absolute value of v of t, the value of the definite integral will represent the total distance that Johanna jogged in meters over the interval from 0 to 40 minutes. Calculating this integral from 0 to 40 of the absolute value of v of t dt, that's going to get us 12 times the absolute value of 200, plus 8 times the absolute value of 240, plus 4 times the absolute value of negative 220, plus 16 times the absolute value of 150. Do all the math, simplify it, you get 7,600 meters. And so the approximate value that we get for the integral from 0 to 40 of the absolute value of v of t dt is 7,600 meters. In part C of this question, we have a second runner, Bob, whose velocity is given as t cubed minus 6t squared plus 300. We are asked to find a of 5. We can easily calculate the derivative of b of t. That's just going to be 3t squared minus 12t equals 3t times t minus 4. And so a of 5, which would be b prime of 5, would just be 3 times 5 minus 4, which is going to be 15 meters per minute per minute. In part D of this question, we are asked what Bob's average velocity is over the interval from 0 to 10 minutes. Bob's average velocity can be found using the formula for the average value of a function. In this case, we have 1/10 the definite integral from 0 to 10 of b of t dt, which is 1/10 the integral from 0 to 10 of t cubed minus 6t squared plus 300 dt, which is 1/10 of 1/4 t to the 4th minus t cubed plus 300t, evaluated between 10 and 0. And when we evaluate that, we get 1/10 of 2,500 minus 2,000 plus 3,000 minus 0 plus 0, which is 350 meters per minute. If you want more AP Calculus AB FRQ solutions, you can subscribe to my channel on YouTube and you can follow me on X.